Hello. So my name is Tatenda, Chawanzwa. I've been a developer for 3 years and so forth. I've used many technologies, which today I want to share with you two, which I really enjoy using and so forth, which is GraphQL and Serverless. I've been gaining headway throughout the industry, and I thought maybe since I use Serverless a lot because it's a nice entry level into the backend, and GraphQL for front end, it makes it much easier to actually deploy a backend service. So today I want to talk about how these two can be combined together in one service. So before we start, I thought I'd do a recap on like what is GraphQL and what is Serverless, because before we dive into how they can work together, we want to find out what they are exactly. So maybe we'll start with Serverless, and the main thing to understand about Serverless is that you need to understand why it's there. So many, especially node developers, we're living in a world where frameworks are coming up left, right, and center. Like if you're a front-end developer, it was Backbone, then it was Angular, then React. So there's a purpose and a reason why these frameworks are there, and there's a reason why Serverless is there. There's a reason why someone thought, okay, let's do Serverless. And the first thing to realize about Serverless is that Serverless is not serverless. So by that I mean that we all need servers. So either way, you're gonna have this. So serverless does not mean you don't have data centers. So either way, you're gonna have a place to actually host your code. In fact, you're gonna have more of it because now many providers. Okay, so serverless, it's not serverless in the state that there's no physical servers, but a definition, Wikipedia, source of all truth. Serverless computing is a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocation of machine resources. So before, imagine you had to deploy a service, you had to deploy a server or a certain API. You had to have the infrastructure. So you had to have like maybe physical machines. You had to actually have like a data center to actually deploy your code, and by that connect that server to the internet and so forth. And you had to like host this, and you had to maintain this hardware, and the entry level to actually produce API, for example, was high. But now, serverless computing allows you just to write a piece of code, and basically you take that code and you upload it. You upload it to any provider. So now the landscape is vast. So now providers can be AWS, probably the leader. There's Azure, there's Google, and so forth. So all these providers, they basically take your piece of code, and basically they using various gateways. Like for Amazon, my talk will be based mostly on Amazon's as a provider. Amazon, there's an API gateway as one. So you can basically route your routes and say / whatever query, go and execute this function. And basically, the good thing about serverless is that the advantages are that firstly, cost. So imagine before when you had a physical server and you had a physical machine, even when your traffic, even if you produced an unpopular site, even if your traffic was down, you still pay for that server. You still pay for you still pay for that cost of actually running a server. But the good thing about Lambda or serverless is that when the traffic is low, basically you don't pay for it. So you only pay for the minutes and the amount of power that your Lambda function or your piece of code actually executes. So that's the one advantage. The good thing is scalability as well. So like what I mentioned, that it's not just about one server. It's about now there's probably multiple. There's more than just one. Because now with AWS, in a way, the bad thing about this in a way is that it's very much vendor locked and you don't know what's happening under the hood. So a very basic, I don't claim to actually know how they implement this under the hood, but I'd imagine that whenever your code wants to get executed, let's say a query comes, basically think Docker and containers. A container is basically sprung up, basically with a Linux environment. And basically, it downloads so imagine serverless is basically you take your code, your function, you package it into a zip file, and you upload it onto some sort of bucket, like S3, for example. And then all that is serverless, when a request comes in, maybe it instantiates a container with Linux and so forth. It downloads your zip file, and it unpackages it, then it runs the code and so forth. So you can imagine that now with AWS, with CloudFront, for example, with S3, they can distribute your function, your code around the world. So it's easily, when someone requests, let's say your server from India, the closest region with the AWS data zone can actually run your code. And proximity actually matters in this case. So it'll be much faster. So it's scalable, and this is something that you get under the hood, as in you get it with no extra cost. I mean, you do pay for it, but then there's something that you don't have to like configure yourself. It comes just by the vendor, and easy development. So before, as a backend developer, maybe you had to like configure Linux environment. You had to configure the server, Nginx. You had to consider like security. You had to consider networking. You had to consider this, and like it was just a headache. But now all that is taken away, and AWS Bezos just says, "Don't worry about it. I'm rich. I can take care of it. You just worry about you run your code. You run your code. Give it to me, and I'll upload it onto S3, and I'll run it." So that's the good thing about serverless, is that the ease of development. Now we see that many front-end developers are actually getting into backend because of serverless and so forth. So that's the one of the main reasons, the good thing reasons about serverless. And it maybe begs the question that, maybe let's serverless all things. Let's forget about containers. Let's forget about, and just, so, but then there is a caveat. There are disadvantages. So one disadvantage of serverless is that code execution. So back to my example of containers. So imagine when the container first springs up, that time it takes to spring up and then download your code and run your code, that time is time that it actually make your request longer. So therefore, there's what they call cold starts in the world of serverless. So basically, when your first request that comes in, it actually has to find a container, spring it up, download your code, and run it. So that cold start can actually delay your request for a bit. But now there is so the good thing is, after that first initial cold start, after the container runs your code, like AWS, they actually keep the container in a warm state. So they don't shut it down for the time being. They keep it in a warm state, and maybe for like 10 minutes, if any request comes in, you can basically reuse that container, then it's quicker. So there are ways you can get around it, but yeah, that's something to consider. And then resource limitation. So a Lambda function, I think AWS, the limit of there is the limit to the amount of computing power that you can put that you can have in a container. So I think, for example, for RAM, you can only have about 2 gig max RAM, and the memory as well. So your Lambda function can't be above 50 MB. So yeah, there are limitations. So if you're building later on, one of the users of serverless on Netflix, but not in the way that you think they will use it. But anyway, and okay, the second thought or third point is vendor lock. So here you're tied to a specific vendor. So I mean, you're tied to AWS. If AWS fail, basically you failed. Basically, if Bezos gets broke, you're broke. So basically, you're tied to a vendor and so forth. So that's the disadvantage. And privacy. So I mean, right now Microsoft and Amazon were fighting for a contract with I think Ministry of Defense in America and so forth. So it definitely they didn't pitch serverless. I actually don't think they pitched serverless, because serverless kind of, it means that their code is kind of, because I think the containers are kind of shared environments and so forth. So I don't think they didn't pitch serverless, I don't think, because it's their code is maybe in a shared hosting, whereas for that maybe you want your own dedicated hosting kind of. So yeah, privacy is one to consider. And then so who's using it? So yeah, it's more or less who's not using it. I think everyone now is using it. From CodePen to the Vogue to Netflix, Coca-Cola Company. I mean, they spoke at a AWS summit, and they even said that how they're saving more than 60, or the amount of money they're saving by using serverless, because before they were paying for every hour that their server was up, but now they're only paying for execution. Netflix. So Netflix, what I spoke about, Netflix, they don't use serverless for their data crunching. So you can imagine Netflix, the speaker spoke of how when they first receive a video from a vendor, whatever, they basically split it and then they convert it into many different formats, like for small screens, for big screens, and so forth. So therefore, in that model, if you use serverless, you're limited in the computing power. So for them, it's more or less, he stated that how they split the video into 5-minute chunks, and basically they then they encode it separately, and basically they use serverless to then have an event to say when all these 5-minute chunks are actually encoded, then a Lambda function then comes together and then combines them together. So the serverless, you really have to know your use case. So it's not a matter of serverless all things. It's a matter of you to study and actually find out what's the best use case. Because for Netflix, maybe running a normal server, an EC2 instance is the best for them for the encoding. So so you need to really understand what's the best way around it. So now that leads us to, so that's serverless, done. Now to GraphQL. So GraphQL, another Wikipedia source of all truth. GraphQL, so I think I won't really go deep into it, but just cover just highlights. So GraphQL is an open source data query and manipulation language for APIs and a runtime for fulfilling queries with existing data. GraphQL was developed internally by Facebook in 2012 before being publicly released in 2015. So you can imagine what's the old school? The old school was basically, there's been many, SOAP, REST. So REST, what is it? It's like a paradigm that we've all basically agreed upon, how different servers can communicate and actually retrieve and give data or communicate with other servers. So basically with REST, you have the part of you have get. If you want to get information, you actually do a get request. You have post. So basically, the best way to actually understand GraphQL is to do like a comparison of REST and GraphQL. That's the best way to kind of understand the two and so forth. So the best way to do it may be to analyze Twitter. Twitter uses GraphQL, but then imagine if this Twitter site, if you were basically hosting this and you had to do this in a REST API. So imagine maybe for this main blog post or tweets, you have maybe a tweet endpoint. So maybe with REST you have get, post, put, delete. So maybe for the first to get all the tweets, you have a get tweets request. So in that get tweets, maybe I'll give you tweets and it's an array of objects, and in there you get all the different tweet data. So basically for each tweet, I can give you the ID, the tweets, like the content, the user, Dan Abramov. If you don't know him, I spelled his name wrong. How dare I? But yeah, Dan Abramov. So basically you can get the tweets into objects, an array of objects of all the tweets, and that's basically a get request. So let's say they come again, the front end team come in again and say, okay, fine, listen, now we want another request for when we click on the tweet. When I click on a tweet, I want to be able to basically have another API call where I actually have more data. So I want the comments of that tweet. So maybe we go. Okay, so fine. Maybe we have another get request to tweet /ID, which is a parameter we can use in our request. And there we actually just return a tweet as an object, and we return more info. So now we return the comments, and basically it's an array of objects of comments of the different thing. So now we have two URLs. And then we've had to bother the backend team again. And then maybe next week, like, listen, I want to click on Dan Abramov, and or maybe to hover over him. And when I hover over him, I want a brief outline of his profile. Then maybe you create another endpoint, say, okay, fine, user /ID Dan Abramov. And they come again next week saying, okay, fine, listen, I want another request, and this time I want when I hover over his whatever, and it's a back and forth. The backend team will just be like, listen, dude, do it yourself. Basically, that's the area that's how they can actually end up getting frustrated. So let's think of how we can actually change this and actually implement this with GraphQL. So GraphQL, the schema language is basically, it works by types. So basically, it's one URL. So in this one URL, it's basically you can make anything you want, /query. And in this one URL, you can basically have a query. And in this query, you can name it tweets. And basically, by saying tweets, and then you can give it whatever argument you want, limit. For example, if I want to limit the amount of tweets I have, so instead of having /tweets, as in get, I can have this tweets query, and then this ending array is basically the return statement. So if anyone has used TypeScript, how many have used TypeScript? Yeah, exactly the same. So TypeScript, you can say this function returns whatever. So whatever, semicolon, then whatever it returns. Same thing here. So here you're basically saying that basically this tweet will return an array of tweets. And basically a tweet is basically a type. So it means there's a mistake I made here, because tweet, they should be a type. They should be a type mark namespace. So basically a tweet is a type. So it's type tweet, and there shouldn't be a semicolon. TypeScript, GraphQL, yeah. Well, maybe it should be, I don't know, damn it. Oh, but anyway, so basically I define what this object is. So a tweet is basically an ID, has a tweet, which is a string, and basically there are many base queries, like base statements, things you can actually return, like or data objects. So there's string, there's int, there's ID is one way, just an ID. So basically, and then you can also have custom types. So basically, if I say user, I can say a user object, and basically in the same schema, I can basically say type user. There should be a type in front of this. I do apologize. So a type user, and a type user is basically has ID and name, followers, and yeah. So it can have basically anything you want. You declare it using the user, and this will basically map to what the data you have in your database or whatever, and so forth. So you declare your types, and maybe even your comments and so forth, and then now on the front end, they only have to call tweets and they only have to call tweets, and then the tweets itself, they can choose what they want from the tweet object. So maybe for here, so okay, I'm kind of jumping. So think. Let's forget about this the filters for time being. So just think on the front end, I can basically say call tweets, and then tweets give me back ID, tweet, and comments. And basically, now the front end now controls what they want. So the front end can say, "Okay, fine, give me the whole tweet object," and basically take whatever they want. Or they can say, "Okay, fine, just give me ID or give me whatever." So now imagine how that's very dynamic. So now instead of us having another endpoint, so imagine now the backend, the front end team come back and say, "Oh, listen, I want to be able to click on a tweet and then have more data like comments and so forth." So maybe for the initial call, I don't want the comments. All I want is a tweet. So basically, all it is, they'll just have to the front end team will just omit comments, and basically the back end won't give them comments and so forth. But now, if they want comments, basically you can all they have to do is basically add comments and basically say what they want. And another cool thing, of which my original talk was supposed to be about custom directives. So with GraphQL, you can have like custom directives. So for example, here let's say they now want to have a specific tweet. So basically they want to implement the /tweet/ID REST API. So now they want to have one tweet, and that one tweet basically has comments, and maybe in those comments you want to have the comments limited to a certain number of comments and so forth. So maybe now you can introduce a concept of filters. So now for tweets, instead of you giving back just a limit, you give me back an object, which is basically or input of filters, which is a tweet filter. And a tweet filter is basically an input, which basically you can define whatever you want them to actually request from you. So limit can be the amount of tweets that you want, IDs. So maybe you can say, "Oh, fine, if you give me IDs, I will basically give you back or array of IDs. If you give me these array of IDs, I'll give you back these specific tweets or those IDs and so forth." So that can be the filter. And then imagine now they say, "Okay, fine, we also want to have limit the amount of tweets we have or the amount of comments we have for each tweet." You can have a custom directive. So custom directives in GraphQL is that whenever you request a certain object or a certain field. So basically, we've said that a tweet has got an ID, has got a tweet for the string of the data and so forth. Has got comments. So comments can be an array of common objects. Then in there you can actually have a custom directive which basically can actually override the default resolver. So in the land of GraphQL, this is basically the contract we have with the front end. So the front end we say, "Fine, there's a query, and then in this query there's tweets, and basically us in the back end we basically have to write a resolver, and a resolver, all it is a function. So for every single query you have, you basically have to have a function on the back end which is named exactly the same as a query, which basically resolves the data that needs to be returned. So let's say I have a tweets resolver. It's basically a function that basically maybe makes a call to the database, and then it retrieves these tweets and basically returns it to you and so forth. So you can tweak these tweets or you can tweak the fields that you actually get from the database depending on the query you actually got from the front end and so forth. So imagine here, you can actually, using custom directives, you can actually override the resolver. So now let's say in this filter, imagine in this comments filter, they can say, "Okay, fine, give me a limit of 10. And then now, when it comes to actually resolve comments, you can write your own custom resolver, which basically resolves the comments variable, and in there it will only fetch the first 10 comments. And then if you want, you can change it so that they can fetch the next 20. Maybe have another filter there that's offset, so you can even like make them. They can be able to even implement their own pagination and so forth. And all this is in one URL and so forth. So now, using one implementation, we basically covered maybe what we would have covered with like 4 or 5 URLs, REST URLs and so forth. So this is the main benefit of GraphQL. So the advantage is that good for complex data systems. So you can imagine like many people, they're coming from a monolith system where it's just like one server and it's massive. Then they want to take the system and change it into more for microservices, whereas like each function or each like purpose or each like business requirement has got its own like a server, like each container, like and so forth. So GraphQL plays a really good role in that it can be like the middleware between the front end and the back end, in that you can make one query, and then bit by bit you can make one microservice to actually collect comments and so forth. And then you take away that, you delegate that work away from the monolith, and you delegate it to that container. And then all it is in your comments resolver, you just point that resolver to the new container. So that way you can slowly move away from a monolith application and into a microservices application without disrupting the front end. That's a good thing about GraphQL. There's no over and under fetching. So imagine maybe with REST, you can actually do it. I mean, so with REST, I can have query params, like queries in the URL where I say limit and so forth and so forth. But then after a while, that fine-grained control that you get with like a nicely schema, with a nice schema, you can't get that. Well, you can, but then it'll be more messy. And then so here, and the front end control what they fetch. So the front end can say, fine, I want this, I want that. They can cherry pick what they want, and it's almost like the front end can control the back end, and the back end team can do less work and actually back and forth like creating URLs, and it's a self-documentation. So with REST now, the technologies that have come about, like Swagger. So Swagger, people have seen that you can build a REST API, but then how do you communicate with the front end and say, fine, this URL does this, and this URL accepts this. Basically, by having Swagger is basically some sort of a documentation where you can basically have it's basically a website which basically documents your whole website, and each and every URL is basically documented in that Swagger documentation. So imagine, for me, I've actually worked with many projects with Swagger, and the amount of work that's required, you do your work, and then afterwards you have to go and actually update this massive Swagger file. And for me, it was a headache, and many times it's out of sync and so forth. But the good thing about GraphQL is, by defining the schema, that's basically a documentation by itself. So it's self-documentation. And then one advantage is subscriptions. So a nice little feature of GraphQL is that you can have subscriptions are basically real-time updates. So you can even maybe have some sort of like a chat app, where basically by using GraphQL subscriptions, you can have real-time communication between two different clients. So there are many advantages to it, and obviously there are disadvantages, like the time to learn. I mean, this is a different paradigm to REST, so you need the time to learn it. And there are performance issues when you have complex like multi-nested queries and so forth. I mean, now they've actually implemented stuff like a data loader, because sometimes you can end up making multiple requests and so forth, which basically brings down your performance. That's something for another talk and so forth. Basically, the N+1 problem is one problem that can exist, which has been solved by a certain degree and so forth. So yeah, it can have like performance issues and so forth. So it is something to consider. But who's using it? Literally, it's more or less who's not using it. So yeah, Facebook, Instagram, Coursera, Microsoft. So yeah, there are many companies which have adopted this technology, and the more people use it, it's open source. So many people use it, and if you need help, there's tons of resources. That's the good thing. About it. So now into the why I think these are a good fit together. So imagine with REST, you have many URLs, but then with serverless, with GraphQL, you only have one request. So you can imagine you have one request slash query, and in there you define all your different queries. And I mean, one thing I didn't mention is there's also like mutations. So I mean, for this talk, I thought maybe I won't dive into the deep concept of GraphQL teach, but rather how they work together and so forth. But then basically, one URL does everything for you. So one URL covers your fetch, your post, your creation, and so forth. So you better make sure that one URL is always up. So it has to be scalable. One, and also it can't fail. So if it fails, you need to have a backup plan. And that's where serverless comes in. Because serverless, one, it gives you scalability out the box. So whenever a request comes in, it can just spring up a new Lambda function. And also, the good thing about it is it's scalable. So, whether you have one user or you have 10 billion, the amount of workload that's required, basically Lambda basically scales accordingly and so forth. So I think, to get to so now I'm probably do my next talk is probably going to go into a little demo with the serverless. So basically, to work with serverless, there are many things you can use serverless. Some people basically, for me, my talk, I'm going to major on AWS. So with AWS, there's something called, you can basically make all your Lambda functions and package them using CloudFormation. So CloudFormation scripts are basically, if you've used Terraform, it's exactly the same thing. It's basically this infrastructure as code, where you can basically define all your resources like Lambda functions. You can define an API gateway, which is, an API gateway is basically how your router. So think basically think of Express, think of slash whatever. That declaration, basically that's the role of API gateway. So API gateway takes your URL and it basically reroutes to whatever Lambda function that you assign to it. But then nowadays, do not write manually, or do not go into the console and basically write Lambda functions. There's now many tools out there, and my favorite, which I'm going to showcase here, is the serverless framework. So this is basically a way to actually, a nice framework where you can actually write a proper API, a fully fledged API, using just a YAML file and maybe your JavaScript code. So basically, this solution is open source, and it takes care of everything. So you can imagine, after you write your Lambda function, you can have many plugins which can take your functions, maybe even minify them. After you minify them, it really it can even argify. Then after it argifies, it then zip it up and then upload into the cloud, and even provision your API gateway, provision everything for you just by running yarn install. So I think now it's best I'll do a little demo of the serverless framework. So the first thing you need to do is actually install npm install serverless. So I actually have it installed on my machine, so I actually won't bother. But all you have to know is that the serverless, it basically, I can't spell. So this serverless, it basically gives you certain commands, and these commands are basically what you use to actually zoom in. Yeah. Yep. Yeah, so these commands, yeah? At the back. Yeah? Yeah, thanks, yeah. So these are all the commands that the serverless framework gives you out the box. So obviously there's configure. So you need to make sure that you actually have a valid AWS account, and then you basically run AWS configure. So basically go onto AWS, install the command line client, then run AWS configure, and basically that will basically configure. Basically you need to have a user, which basically you collect the access ID and the secret access ID. Basically that's what you use to put to configure, so that this basically use that information to upload to your specific AWS account and so forth. So with serverless, let's say, with serverless, if you wanna, so with serverless, if you wanna install start a new serverless framework, you basically say serverless install, and okay, so with serverless you can have, that's a good thing about it, it's open source, so you can have many templates. So obviously these templates are basically a little blueprint you can start your project with. So you can imagine here I'm using this anomaly, whatever, this function from these lot, serverless node.js starter. So it's good to mention that with serverless, you can use many languages. So Lambda, you can use Golang, is gaining popularity. Python, you can use .NET. Don't do it. .NET is not, yeah, it's not the best for serverless. And then, so you basically here, I'm using the Node.js starter pack, and the name, maybe I'll say it's serverless API. And by doing that, it will basically create for me, it will basically create for me a serverless project out the box. So, yeah, so basically what I have here, it gives me tests, of which today I won't cover tests, so I can delete that. But the main thing you have to realize about serverless framework is that everything, this is where basically the magic happens, is basically this serverless.yaml. And the serverless.yaml is basically where you actually configure like what Lambda function actually, what Lambda function is actually used for what route and so forth. So maybe first of all, you give it the service, which service is, okay, you can't have happens. So you give it the name of your app, which is serverless API, for example. You can have many options like package. I mean, they have a documentation on the website, so you can read it yourself and so forth. So package individually, this means that for each, so basically imagine this certain framework, this certain like plugin I used, basically it uses Webpack. So if you've used frontend, Webpack is basically a nice bundler which you can use to actually bundle your code and so forth. So using Webpack will actually bundle each function individually and make it so that it uses the libraries that are actually required or imported within that Lambda function and so forth. So yeah, you can have many options. Plugins, there are many plugins. So I mean, today I'll probably highlight the serverless offline plugin and so forth, but there are many plugins you can use. Here, the serverless bundle is basically what you use is a Webpack bundler, basically. And then provider is basically the name. So basically, there's AWS. Maybe you can have Azure, Microsoft. You can have Google and so forth. So yeah, and the runtime is basically Node.js 10. So basically, you can have different runtimes. So maybe I think the latest they actually support is Node 12. I think. And stage region, the region of where you want to upload your code on in AWS and so forth. So yeah, there are many providers you can options you can have for that. But the main thing is functions. So functions are basically the function that you want to run for a specific route. So imagine you say functions, and then you declare, let's say this one's called hello, for example. It's called hello. Maybe I'll call it GraphQL. This thing doesn't matter that much. And the handler is basically the path to your handler. So in this case, is this. So basically, what I'm saying is that the handler is basically handler.hello. So basically, in this JavaScript code, hello is basically my handler, for example. And then events are basically like your router. So basically, it's saying whenever an HTTP request comes in, the path is /hello, and the method is get. If that matches, you run this code, run handler, and that's as simple as and so forth. So for us, this is nice and so forth, but we want to change this so that it uses serverless. And to do this, there's one library we will need, which is basically I don't know if anyone has used Apollo Server, but they also have a different offering, which is basically Apollo Server Lambda. And basically, Apollo Server Lambda is basically the offering for Lambda functions. So in a way, when you have your handler, you can take this away. So we can say, okay, fine, for a path, we want it to be query. And then, okay, I'll skip this for the time being. But in there, we can say import Apollo Server from Apollo Server while it downloads the entire internet. What the hell? Yeah, you can't wait. Okay, Apollo Server Lambda. Yep. Okay. And then basically all it is, we have to create our handler. So basically with Apollo server is very simple. You say a handler and you say equals new Apollo server. And then in there it can take, so if you've used Apollo server like without serverless, exactly the same thing. So obviously it expects type defs, which are basically your schema, your type definitions. So this is like, if you think of the query and so forth, that's where you need to provide a basically a file where all these type defs are. So basically it expects type defs, it expects resolvers. So basically to every single query, like what I said, every single query has to have a subsequent resolver which resolves that query and returns data for it. Then apart from that, you can also have a context. So context is that if you want to have, so context is a function. Basically, if you want to have data to be persisted, I mean, I'll show you the resolver code, to fully explain this. But if you want to have data to be persisted through different resolvers, you can basically pass a context object. And this is where, for example, if you have some sort of like a library to actually fetch data from a database, you basically add that model, whatever, to the context. So basically, I think here for serverless, you get the event. So event is basically the the AWS event. So when the request comes in, you can get event.body. But then for serverless, it doesn't really matter because we use something else for that. You can have you can have many things here. Then all it is, you can then basically this basically returns an object. So in this case, so okay, so in this case, we have to create type defs. And these type defs are basically our declaration for our server. So I mean, before I actually prepared a small little type def, so maybe I call it just, I don't know, type defs.js. Then in there, we basically have our schema declaration. So okay, this was basically alias to make it easier. It's nothing to do with serverless. This is basically an alias that I made so that instead of typing everything, it just copies the code from somewhere. Yeah. But anyway, basically, this is basically our schema. So basically, Apollo Server Lambda basically provides you this service, GQL, which basically converts a schema, this into a schema declaration, basically. So basically, I mean, the good thing about having Webpack, so here it is a JS file. But the good thing is with serverless is that, for example, you can have like a bundler. For example, with Webpack, there's some even like other libraries or plugins where you can actually have a physical webpack.config in your file, and in there you can do whatever you want. You can install a TypeScript loader, and basically have TypeScript throughout your code. You can install maybe even there's a GraphQL loader where you can actually, instead of having a JS file for your schema, you can basically say typedef.graphql, and basically it can be a full-fledged GraphQL. You can basically import a full-fledged GraphQL file and so forth. So yeah, the landscape is vast and so forth. But in this case, I just use this GQL from Apollo Server Lambda, and basically I just declared my type defs, and it's a matter of just importing them. Type defs. So now I've got my type defs, which I've got here. Then now all I need now is my resolvers. So basically, maybe here I'll create a resolvers file, .js. Then, like I said, so resolvers are basically functions that map to your type defs. So imagine here, I've basically declared, okay, fine, I have a query, and that query, you can basically ask for a worker. So this is a different talk that I made for the front end. But yeah, basically, I can basically declare a worker, and basically you can get back a worker. And the worker is basically an object with the ID of the worker, the first name, the last name, the email, and so forth. And that's what it is. So basically, I can say worker or workers and so forth. And then basically, in my resolvers, I have a query, and basically I need to have a resolver function which basically resolves to that specific query. So here I have a worker, and basically here, all this is a resolver function. You get about four parameters. arguments, which is the root, which is basically the data the data that's been collected already is basically okay. So when the request comes in and it's basically hitting all the different resolvers, it'll basically collate all this data, and root is basically the collection of all this data. Then arguments are the arguments that the user can actually give you. So for example, ID can be it will be part of args. So here I say args.id. Then the worker is basically here when I declared my context, right? I can basically pass in I can pass it certain models, and these are basically maybe classes to actually communicate with my backend. So for example, if I create a model here, and then maybe, so this is a very simple a model where basically I use DynamoDB. So basically I'm connecting to, yeah, okay, so yeah, so I'm basically connecting to DynamoDB, and basically I'm collecting data from DynamoDB and so forth. From DynamoDB, and basically I can basically import that and basically give it the worker. And then basically what I put in the context is basically available in every single resolver. So the third argument is basically context, and it has the resolver object. So basically here I have worker.fetch, for example. And basically if you look at the models, it's basically fetch is basically a command where I just I basically fetch data from the DynamoDB table, and that's it. And then I basically have many more here, but yeah, time, I actually won't go into it. But yeah, so now that by doing that, then afterwards, all I have to do is say exports dot handler equals maybe call this server equals server dot create handler. And then that's it. Then here in your serverless YAML, you say, okay, fine, whenever a function comes in, go into a handler and then run handler to handler. Yes, bad naming, but anyway. And also, okay, fine. Then I say that, okay, fine. I can actually omit method because, for example, if you use a Apollo server, you can have a playground which you can play with locally and so forth by saying true. So basically, a playground when you hit /query/get, you can basically have this playground where you can basically play with your server in the meantime. So for post, it'll basically be retrieving the data, and for get, it'll basically host this server. So when you have that saved, literally, so using, as I said, the marketplace is vast. So there's a plugin I use there, which is Serverless Offline. And so the good thing about Serverless Offline, you can actually host, without deploying, you can basically self-host your serverless function or framework API locally. So if I just run serverless, or SLS for short, offline start, I do apologize. Okay. Yeah. Sorry. Okay. So for method, it needs argument. So for method, we say here. I'm saying that for method, any. So any HTTP on /query, just go to the whether it's post or get, just go and run this function, and then this create handler will sort it out. So now if I go to localhost 3000, nothing is there. But if I say /query, live coding is actual. is actually actual beast. So okay, so my bad. So you have to have here for the models. I'm using the AWS SDK. So I actually forgot to download that. So yeah, basically, once you have that SDK installed, you can basically have your function running. Yep, you can basically have, yeah, so now imagine with this locally, you have your function running, and let's say here I have a workers query. If I call that, there you go. So in the DynamoDB table in my AWS, I actually have pre-formatted data, and basically you can get that data. So imagine in just like 5 minutes, 10 minutes, I basically have a fully fledged API. So I mean, one thing I was gonna, I don't know how much time we have, but one thing I was gonna mention is that if you wanna save money, this will save you money. This is important. So a really good, which I discovered just a while ago. Okay, so API gateway can get expensive. So API gateway is what they use to actually have the routing system, and the routing system actually goes to your different Lambda functions. It can get expensive. So I mean, there's one like article that this dude made where he actually compares API gateway and an application load balancer. So a load balancer, I mean, if you use in the world of servers, you can use like for example an Nginx server to actually have a proxy which basically routes to different servers. So you can distribute your load between different servers. So if you have high traffic, that load is distributed between different servers and so forth. So the application load balancer plays the same thing, but then it's an AWS offering. So here he actually compares the prices. So when you have many requests per second, the amount of money you pay for API gateway, so for the root actually hitting API gateway, is way more compared to just so your cost won't be to actually running DynamoDB or Lambda functions. It will be mostly the API gateway. And he was saying that if you take out API gateway and substitute with a load balancer, you can save about 65%. And it varies, but then you can save a lot more. So and the good thing is now AWS introduced a feature where you can actually reroute a load balancer. You can actually reroute routes from a load balancer, and you can reroute them to Lambda functions and so forth. So therefore, it's something that's to consider, that if you have a high voltage of request, it's probably best to actually do that. And then this is, I mean, if you've used CloudFormation, so in your serverless function, you can have resources. And resources is basically a CloudFormation script of how to configure server. You can configure anything: servers, Lambda functions, and load balancer. So if you want, this is basically the script to actually have a load balancer. And basically, into a load balancer, basically, if you never use CloudFormation scripts, just think of it this way. You basically here, the top half, I basically created a load balancer, and basically I create a listener. A listener is basically a fine. A listener is basically, okay, fine. Whenever I get a request, basically reroute it to here. And then basically, here I'm saying, like, fine, whenever I get a request from a listener, reroute it to this specific target group. And that target group down here is basically a target group which basically points to Lambda functions. So you're saying that the target type is Lambda functions. Then, for example, in your functions, you substitute GraphQL, and for events, instead of HTTP, use ALB. And the ALB, all it requires is a listener ARN. So if you're familiar with AWS, ARN is basically the unique identifier for each resource. You basically give the listener RAN, and basically the priority, the conditions, and the path, and basically you save yourself 3,000, which I would want a portion of, because I've just told you this little hack. So quickly, I'm basically done. So